This is Lab 2, Projectile Motion by Kaylee Shacklock, which is me. Hi, how are you doing? Introduction. This week's lab focused on projectile motion. The focus was compare projectile motion to a predicted model. We focused on projectile motions, how projectile motions act differently with and without drag, and how initial velocity and initial position impacts its course of motion. Fundamental concepts include Newton's second law, F net, which is the first one being gravity only, the second one including drag, and the drag equation is listed right there, velocity and projectile, and an understanding of projectile motions. Overview. The purpose of this lab was for students to demonstrate and analyze projectile motions in the real world and compare it to a computationally made model. Procedure. One was to throw an object in a projectile motion and analyze its movements with tracker. The second step was to create a computational model using GlowScript to predict position and movements according to the information given in tracker. And step 3 was to graph and compare two sets of data. Video. This is my video. It's just me throwing a paper ball. I was at work when I took this video. The system is the paper ball, surroundings is the table, my hand, and everything else. Alright, here are my graphs from tracker. This from right here up until the 8th second, that's me like moving my hand, and then at this 8th second is when the actual ball is thrown, so it kind of goes up a little bit, and then so on and so forth. Here are my codes from GlowScript if you're interested. Here we go. GlowScript graph. And here's the comparison. Overall, they relatively line up at this beginning, but then kind of fall off. Not too horribly. Honestly, I was just a little confused because with my motions, my hand did flick back and caused a lot of issues as far as that. So that was one of the errors that were definitely made within my lab. So that was definitely room for improvement and room for error analysis was within this kind of comparison and within the code and comparing the two. Especially in the far as time in seconds. The video was 3 seconds long, but my movement of my hand was most definitely less than 3 seconds. So I guess had I cut it shorter and only analyzed the video from the time that I had actually moved my hand and everything past that, my data would have came out much more correct. So that was some room for error. What does it mean? Terminal velocity happens when a freely falling object experiences zero net force. Examine the velocity versus time graphs predicted by your models with and without drag. Do any of your models predict terminal velocity? If the answer is no, what similar experiment could you design to find the terminal velocity of your object? My object did not experience terminal velocity because terminal velocity, the gravity is balanced by drag, which results in stopping of acceleration. In my experiment, the object didn't have enough time to reach the terminal velocity. So a similar experiment I could have would be to drop or throw something from a higher y value, higher up in the air, and then measure from there. Imagine if the object were initially thrown straight up with the same initial speed in your experiment, would the time this object takes to reach the ground or floor or table be the same, longer, or shorter than the time it took in your original experiment? Discuss briefly and justify your answer with equations, calculations, or computations. For me, it would take a lot longer to hit the ground because it would slow down first, reach its highest height, and then fall back down, resulting in the time being longer than the original. And then if it had drag, it would be even more slower than that. Thank you for watching this. Bye-bye!